And welcome back, students. We are starting a new unit on logic gates. We're going to start off by first talking about some common logic gates. We're going to start off with our first one, which is AND. Now, you might be wondering, what is a logic gate? Is this like a gate constructed out of my teacher's weird logic? Well, no, not quite. Instead, a logic gate is an implementation of an idealized or a physical device that carries out a Boolean function, which is usually dictated as true or false. Now, logic gates typically will act as electronic switches that change states. So recall, if you will, that binary was a state of 0 or 1. We used 0 for a low voltage state and 1 for a high voltage state. True false, which is what we're going to be dealing with here with logic gates, is a binary state. Typically, we'll represent true with a 1, and we're going to represent false with a 0. So let's go ahead then, with that in mind, look at our first logic gate, which is AND. And we'll look at a couple others throughout the coming days. So an AND logic gate is one that implements a logical conjunction. Conjunction means that it's taking two different states, testing them, and getting an output. And it behaves according to the truth table below. And we'll talk more about truth tables later on in this course. All right, so what this logic gate AND means is that both conditions, A and B, so you're testing two things, must be true in order for our answer, our output, to be true. All right, and here is that table, but now if you look, it's given to us in states of 0 and 1. So we have our first state A, it's set to 0. We have our second state B, set to 0. Then I should set my output to be 0. If I have a state A set to 0 and a state B set to 1, then that output will also be 0. If I have a state A set to 1 and B is set to 0, then my output will be set to 0. Similarly, if I have A set to 1 and B set to 1, then my output is set to 1. Now, it's a little bit harder necessarily for us humans to look at this with numbers, so let's actually put this in terms of true-false, which is a lot easier for our brains to process. So here's that same truth table. And we went and replaced all the zeros with false and all the ones with true. So this actually makes it a little bit easier for us to look at. So A is false, B is false, the output is false. A is false, B is true, the output is false. A is true, B is false, the output is false. And lastly, when A is true and B is true, then the output is true. So you can see here that it's pretty quick. You look here and say, hey, the only time something's going to be true is when both things are true. And that's the nice thing about AND, is that you know you have to have both true in order to get one true. So it's, in a way, a very nice, easy thing to look and process that. You're not having to try and determine if one states this way and another states this way. It's just, no, both states have to be true. So the logic gate of AND is typically represented with a symbol like this. All right, you'll have in here two states. You'll have your A state and your B state, and here's their conjunction, so they're both feeding into this same circuit. And then they're going to produce this output. So this is the diagram that is used. All right, it's one. There are several different standards, but here's the one that we're going to be looking at. You'll notice that both A and B, as I mentioned, are outputs and generate, or inputs, excuse me, and generate an output labeled Q in this diagram. Sometimes you'll see a label like Y, or you'll see this says output. Ultimately, it doesn't really matter. All right. Now, you're probably wondering, how does AND work? Well, let's just test this using a simple example. And if you're wondering why we're looking at logic gates, well, logic gates are used in the fundamental field of computer science all the time. So let's just test this with a very simple example, and we're going to check to see if a number is between 1 and 100. Nothing too complicated. All right, just check to see if a number is between 1 and 100. So first thing I'm going to do is I'm going to check to see if that number is bigger than 1, because I have to test two things. I have to see if it's bigger than 1 and smaller than 100. So I'm going to start with the bigger than 1 first. All right. Now, obviously, this is either going to return true or false, because the number either is bigger than 1 or it's not bigger than 1. All right. The only time you might run into something iffy is if it's equal to 1. But then if it's equal to 1, is it bigger than 1? No, because then it'd be equal to 1. So here we're just saying, is it bigger than 1? Then I'm going to test to see if the number is smaller than 100. Now this is going to return either true or false. So if the number was 99, obviously it would be true. If the number was 150, it would be false. And if it was 100, as I said before, it's equal to, which is not the same, equal to would make it return false because we're looking for between 100. We're not including those two numbers. So anywhere from like 2 to 99. So let's look at an example here. Let's test the number 43. So first I'm going to test to see if the number is bigger than 1. Obviously this should return true because 43 is bigger than 1. Then I'm going to test to see if the number is smaller than 100. This is also going to return true because last time I checked, 43 is smaller than 100. Since both of these conditions are true, the logic gate, the AND gate that we just looked at earlier, will return an answer of true. Because remember we said both the conditions have to be true in order to generate an answer of true. Now let's look at a second example real quick here. Let's test down the number -7. Right? So we're getting to a negative here. We should expect, hopefully, to see a different output than we did before because we know just logically -7 is not between 1 and 100. But here's how the computer is going to go through it. First, it's going to test to see if the number is bigger than 1. Obviously, this is going to return false because is -7 bigger than 1? No, it's smaller than it. Then it's going to test to see if the number is smaller than 100. Well, this is true. Even though the first one's false, the second one is technically true because it looks at each condition individually. It's going to say, hey, -7 is smaller than 100. That must be true. Now, it's going to now bring those two conditions together, and it says, hey, my first condition is false. Second one is true, but it doesn't really matter here because since the first condition is false, we know because it's an AND logic gate, the entire logic gate is going to return an answer of false because remember we said both conditions with an AND need to be set to true. And that concludes this lesson, ladies and gentlemen. And next time we come in, we'll be talking about more logic gates. And until then,